In this particular video, I will discuss about Java collection. A collection is an object that groups the multiple elements into a single unit. So it is very useful to store, retrieve, and manipulate the data here and transmit the data from one method to another. So collection framework is a unified architecture for representing and manipulating the collection. A collection framework contains three things. One is nothing but interfaces, implementation, and algorithms. So this is the collection framework diagram. So in the dotted rectangle, we have interfaces here. So iterator, collection, map, list iterator, list, set are nothing but the interfaces. Array list, linked list, hash set, tree set, hash map, tree map. So these are all the classes. Okay. So defines the fundamental method. So we have a size, we have a is empty, contains method, add method, remove method, iterator. So these methods are enough to define the basic behavior of the collection. So when we are trying to demonstrate, we'll try to see what all these methods. Okay. Provides an iterator to step through the elements in the collection. So defines iterator interface defines three fundamental methods. So first one is next, second is has next, and third one is a remove. So these three methods provide access to the contents of the collection here. An iterator knows the position within the collection. So each call to the next reads an element from the collection here. So every time we are going to call the next, it is going to read the element from the collection here. So this is the iterator position. We have a first position here, and it's go on iterating till you get the last element. So this is an example for the simple collection where we are trying to add the we are trying to create an array list, and we are trying to add the elements from 1 to 10, and we are trying to display them by making use of a iterator here. So in this particular diagram, we will try to discuss about what is a collection. Collection has two different interfaces, list and set. So the first one is a list. So list interface adds the notion of order to the collection here. The user of a list has a control over the element is added in the collection. So user can go on adding the items here to the collection. So list typically allows the duplicate elements. So you can have duplicates in the list here. So provides a list iterator to step through the elements in the list here. So we can iterate by making use of a list iterator. So list iterator interface. So extends the iterator interface. Already there is a iterator interface. It will extend the iterator interface here. It defines three fundamental methods. So we have a add method, we have a has previous and previous. So the addition of these three methods defines the basic behavior of the order list. So you can the addition of these three methods will define the basic behavior of the order list here. An iterator knows which position knows the position within the list. So we can tell exactly which position is there by making use of a list iterator. So this is the list iterator here. We have a next and previous method. We can go on using next. We'll get the next element. If you use previous, we'll get the previous element. Okay. So we have a array list and linked list here. And what is a list implementation? We have array list and linked list. What is advantages and disadvantages? We'll try to understand. Array list is low cost, random access, and array list is high cost, insert and delete. Arrays that resizes if needed. If you want arrays that want to resize, you can make use of array list and linked list. So array list is low cost random access and high cost insert and delete. Arrays that resizes if needed. So linked list has a sequential access, low cost insert and delete, high cost random access. So what is array list overview? So this is the constructor for array list here. It will take initial capacity. If initial capacity is less than 0, it's going to throw some exception here. So array list method. So we have a get and set methods that can be used to get the element and set the element, or else we can use add or remove method. May want to resize in one shot if adding many elements. You can resize by in one shot by adding many elements by using ensure capacity method. Linked list overview stores each element in the node. Each node stores a link to the next and previous node. So here each node stores the link to the next and the previous node here. Insertion and removal are inexpensive. So already we have seen is insertion and removal are inexpensive. Linear traversal is inexpensive. Random access is expensive because we have to start from starting. Okay, because of these reasons, the random access is expensive. The list is sequentially, so access it in that way. So we can make use of a list iterator to access. List iterator knows about the position, add and remove elements. We can go on adding and we can remove that. So linked list knows a few things like add first, add last, get first, get last, remove first, and remove last. So these are the linked list method. We have a set method. We have a hash set and tree set here. So same collection as the same method as a collection. So with no duplicate entry. Set will not allow the duplicates, whereas the list will allow the duplicates. Okay. No duplicate entries defines two fundamental methods. So we have add methods, reject the duplicates here, and iterator provides iterate among all the elements, provides an iterate to step through the elements in the set. So we have a hash set and tree set over here, and hash set means find and add the elements very quickly. Hashing uses the array of the linked list. Hash code is used to index into the array, and equals method used to determine if the elements is in the list of the elements at that particular index. So hash code methods and equals must be compatible. So we'll try to see like what exactly how to use these methods when trying to demonstrate. Okay. So tree sets, the elements can be inserted in any order. Okay. The tree set stores them in the order. The iterator always present them in the order here. So default order is defined by natural order. So we'll try to understand what or how exactly this tree set works. Okay. Later. And we have a map, we have a hash map and tree map. So here it stores the key and value pairs, maps from the key to the values. The keys are unique. So in this particular case, the keys must be unique here. A key can map to only one value. One key can map to only one value. A single key only appear once in a map here. So values do not have to be unique. So values you can have duplicates. For example, key number one may be and key number two value can be same. Okay, key number one value and key number two value can be same here. So values do not have to be unique. So we have map methods. We have put method, get method, remove methods, contains key, contains value, size, and is empty. So we have different type of map methods. So put method again get. We want to remove the map element. So whether it contains the key, contains the value. So we'll try to see what or how exactly these methods are in a demonstration. Map value. So the means of iterating over the keys and values in the map. So set key set returns the set of keys contained in the map here. Collection values returns the collection of the values contained in the map. This collection is not a set as multiple keys can map to the same value. So here the multiple keys can map to the same values, and so the collection values is not a unique. Okay. So entry set returns the set of key value pairs contained within the map here. Okay. If you want key and value pairs both, we'll try to make use of the entry set. So we have a hash map and tree map that we have understood in this particular chapter here. So hash map is the keys are set unique and unordered. So here the hash map is unordered, but the tree map is ordered. So that is the difference between the hash map and the tree map. The keys are set unique and ordered. So in addition to the basic operation, collection may provide the bulk operation. So you can add two different collections. So all the elements of the collections by using add all, or you can remove all the elements in the collection by using remove all, retaining the two different collections. If some common elements are there, we can make use of retain all. Okay. So utilities. So the collection classes provides a number of static methods for fundamental algorithms. So we have a sort, search, shuffle, reverse, fill, copy, minimum and maximum elements. So this is the summary of that. We have a iterable interface. We have a collection and we have list, queue, and set. And in the list we have array list, linked list, stack, vector, and queue we have a priority queue. And we have set, we have a hash set and linked list, link hash set. Okay. In sorted set we have a tree set here. So tree set is always sorted. So let us try to understand further by practically implementing it. Okay. So I'm in Eclipse here, Eclipse window. Now what I'm going to do is I'll try to create a first one is array list. Okay. So how to create array list? So I can use array list, or you can just say list. So S1. If I say the element, the name is S1. So we have a array list. Array list. So I want to create it for string. So I make use of a string here, and here also it is a string. So make use of a string. Okay. So what I'm going to do is I will try to add the elements. Okay, s1 dot add. So I will add some name. Okay, so s1 dot add. So I'm going to add one more element, s1 dot add. So I added three different names. Okay. So now I'm trying to display all these names. So how to display this? We can make use of a iterator function here. So I will define the iterator function. Iterator. Okay. So string. So here the iterator is must be typecasted with the string here. So I can use it and the name of this is s1. Okay, s1 dot iterator function. So now we can iterate by making use of the while loop here. While it dot. So here we can make use of as next. Okay. So value can get the return the next value of the will return the next value. So let me try to run this. So here I am able to display all the names of the list here. Suppose if you want to delete the any item, so you can make use of s1 dot remove. Okay. So provide the index. If I say 0, the first element will be deleted. The first element will be deleted. So like this, you can go on saying s1 dot remove s1 dot first add first. So we can make use of we can add the first element here. Okay. So the first element, if you want add the element to the starting location, you can make use of the add first. So uh, the 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 name is added here. Okay. So like this, we can go on adding the elements. Okay. So the next one is like by making use of the linked list. So you can make use of a linked list. So same thing. Now it is a linked list. So here also I can add first, okay, add last. So these are some of the methods that I'm having. So I can make use of a get method also, like get 0, get 0. So here I can say system dot out dot println dot get the index 0. Okay. So run this. So the first element is getting displayed. Okay, this is the first element. So it is getting displayed here. So the remaining elements are iterated in this particular fashion. So the first element is removed over here. Okay. So nowhere we cannot find the first element here. So in this way, I can use get method also. We can use put method also if you want to make use of. You don't want to add, you can make use of put method. So put s1 dot. So it's not put method. Set. Okay, it is a set method. So I can make use of 1 comma something like. So this is how I inserted one more record inside here. Uh, so this is the linked list implementation. So one more thing, we are having the set. So set will not allow the duplicates. So here you can add some duplicates. Okay, you can say. So you can see that the duplicates we have added. Okay, so the same name is getting displayed twice. Okay, so in this way, I've added this name Girish, so it is getting displayed twice here. So the next thing we try to understand is the thing but the set. So set will not allow the duplicates. Okay, so I can make use of a set. And here I say, so the one is like hash set we are having. Okay. So same methods we can make use of. There is no any set and this methods. Okay. So not have this methods. Run this. And we can see that all the names are getting displayed, but duplicates they are not allowed. Okay. So these are the duplicates. Akash is duplicate and Girish is also duplicate. So when you are making it as a set, it will not allow the duplicate. So we have a tree set also. So also you can make use of a tree set. The same methods we are trying to apply here. So in this way, I'm able to display all the records. So coming to the next thing here, now how to one more thing is like having the map values. Okay, so you can go for a map here. So map. So if you want to map uh, key and values, I will take integer as a key and value as a string here. So here I can say like hash map. Okay, new hash map. So here also you can say like integer comma string. So here what I'm going to do is I will try to add okay s1 dot map 3 comma. So can make this so I'm able to put three different names over here. So one s1 dot put s1 s1 dot put s1 dot put and so s1 dot put. So like this three different names were. So these are the first one is nothing but the key and the second row is nothing but the value that is corresponding to this particular key here. So how I'm going to iterate by making use of this function. So this won't work for the uh, key and value pairs. So string entry is equal to s1 dot entry set. So get the value here and string integer k. Integer k is equal to entry dot get key. Okay. So in this way I'm able to get the key and the value pairs here. So system dot out dot println. So the value and one more is the integer value. So you can say k. So let me run this. So I'm able to get all the key and value pairs over here. So, or else we can make use of some function like system.out.println. So here I can have s1 dot get the object. You can pass the key over here. So I can say 1. So what is the value it is going to return? So it is going to return the value. So in this way I can retrieve all the values and key pairs by using the hash map here. So there's one more thing. We have a tree map also. So that also can be used. So this is how we can make use of a tree map to display all the records here. So we have a stack and a queue. So that is what I'm going to discuss here. And this function is a built-in function. So we have a integer. So s1. So this is how we try to add s1 dot. Uh, so here it is a new stack of integer. I'm trying to create the stack of integers here. So here I say s1 dot add the integer. So I'm going to add 10. Okay. S1 dot add 20. So S1 dot add 30. So I'm going to add three different numbers. Okay. So I make use of a for loop here. So to display, or you can make use of a for each loop. Okay. Stack S1. You can make use of a string or integer value. Integer. Yes. So here we can have a S1. Okay. I can display the value of S. So the value of all the elements will be displayed here. So this is how it will display all the elements of the stack here. So I can make use of a push and pop operation also. Instead of add, you can have a push operation. Push of. So 40 also. So that can also be used. So I can make use of for each loop to display all the elements. So this is how you can use, and also you can make use of a pop to delete all the elements in the of the collection. Okay. So you can make use of a pop method to delete all the elements. So in this way, I can again go for a pop. So it will delete it two elements. Okay. So this is how we can have a stack here. Now I can have a queue also. Okay. So queue, and here I can have priority queue. Priority queue. So this is the integer here, and here what is the value? S1 dot S1 dot. So here it is insert element. Okay, insert, or you can say contains. So you can have put add method. Okay. So add method is the 10 comma s1 dot add 20. So here I'm going to add two different elements to the queue and third element to the queue here. So I can have a s1 dot. So I can have pop element. Okay, so pop, pole also. Okay, so that is better. S1 dot pole. So that is also going to delete the elements from the queue here. So 30, 10, 20 are deleted. Only 30 is going to be displayed here. So this is how the queue and the stack are implemented in the collection here. So this is what I have discussed in this video. If you like this video, subscribe to the channel. Thanks for watching this video.